Greetings, everyone, and a warm welcome to the day 2 of Durham College's Enable AI Summit. My name is Vibha Tyagi, and I'm the manager of Applied Research Partnerships. My specific role in the Applied Research Office and with the AI Hub is to formalize the industry partnerships, manage the administration of the grant, and most importantly, bring more grant funding to support the amazing work our team is doing. Before we begin today, I would like to take a moment to acknowledge the land upon which Durham College is situated. It is on the traditional territory of the Mississaugas of Schuylkill Island, First Nation, and the territory covered by the William Treaty. And we're thankful for the opportunity to be here. This conference showcases how AI Hub is making a difference in the growth of its partners, such as the community partners, its faculty members, most importantly, our students. Last evening's fireside chat was a true example of the growth curve that our students can experience. Personally, I feel educated and honored to be part of this team and to be with this creative, committed, and hardworking team. Working closely with them, I now know that Python is not a snake, it's a language. Another important thing that I learned over the years by seeing those successful outcomes that AI projects aren't purely an IT function. As Ali said, AI does not work in a vacuum. It is a multidisciplinary function. At the AI Hub, majority, if not all project ideas, they come from outside of IT departments. And at today's conference, you will see how healthcare professionals, market analysts, project managers, and others have all inspired the AI ideas and developed them in collaboration with our student and faculty. So if any idea comes to mind, contact me on Twitter or by email. My email is vibha.tyagi@durhamcollege.ca or appliedresearch@durhamcollege.ca. And I'll be happy to move things ahead. Speaking of inspiration, it is time to introduce our keynote speaker, Ramzi Abdelmoula, who leads AI innovation at General Motors. He's an accomplished leader in applied AI with a deep knowledge of neural networks, IoT, and advanced machine learning. Today, Ramzi will share a little bit about his journey with AI through GM and will give us his perspective on where he sees AI is going. While watching the session, you can ask questions in the chat feed or you can tweet at the AI Hub, and Ramzi will receive these questions and he will respond if the time is permitted. So Ramzi is based in the Durham region, and let us give him a hashtag DC Proud welcome. Ramzi, the floor is yours.
Thank you, Reba. Good morning, everyone. Thank you for inviting me to be part of the Enable AI Summit 2021. And thank you to our students and government partners who are interested in learning how General Motors is using artificial intelligence to make a global impact. My name is Ramzi Abdelmoula, as Reba just mentioned, and I'm the managing engineer of the Artificial Intelligence Innovation at GM's Canadian Technical Center, which is also known as CTC. There's a lot of exciting things happening across GM, and particularly at our CTC in the areas of AI. Let's first talk about what is artificial intelligence. In my opinion, it's not just a tool. It is a massive technological trend and a new way of looking at data and algorithms, pushing the boundaries of what machines can do for us. It's already around us and has become a normal part of our daily lives and businesses. AI is present in our phones, sports analytics, manufacturing, production, inventory management, and retail experiences. It's also part of our vehicle and safety systems and is a technology that's going to take us into the future. As this area continues to grow, AI will continue to benefit our lives in many ways. And while GM is historically recognized as a manufacturing leader, the automotive and tech industries are colliding. With each passing day, GM is becoming more and more a tech leader. To talk to you about how GM is using AI and machine learning, I'd first need to share with you GM's vision for the future. Our Canadian engineers are playing a role in that vision, and they're leveraging the power of AI and machine learning to help us get there. I'll provide as many AI examples as I can, with the caveat that a lot of what we do at CTC is proprietary, but I'll tell you firsthand, it's an exciting time to be an engineer in the automotive world. Before we begin, let's pause to look back. When automobiles replaced horses and carriages more than 100 years ago, they fundamentally transformed our world. They brought job and prosperity, and for so many other people, economic and social freedom. But that positive change came with an unintended consequence, which are crashes, causes of injuries of death, emissions that contribute to climate change, and congestion that clogs our roads. These are real problems, and General Motors is using its technology, its talent, and its expertise to solve them. Our vision is a world with zero crashes, zero emissions, and zero congestion. Ultimately, we believe the future of personal transportation will be electric, autonomous, and connected. It's coming faster than you may think, and it will be better for our customers, for society, and for our planet. Led by Mary Barra, our chairman and CEO, we're working on this future today. We are at an inflection point, and we're about to see a massive change in the automotive industry. Artificial intelligence will play a critical role in this transformation. The drive to build a better world comes from General Motors' heritage. As an iconic company that has been innovating for more than a century, we see things as not as they are, but as they can be. We developed the first electric starter, the first production V8 engine, first automatic transmission, and first airbags. In addition, on the connected side, our industry first OnStar connected vehicle technology has given millions of customers peace of mind and has helped first responders save lives. GM has also used its innovation and resources to make significant contributions beyond automobiles and continues to do so. Last year, at the beginning of the pandemic, GM stepped in to help meet the need for critical PPE in Canada. In just 3 weeks, we transformed part of the Oshawa plant to produce face masks. With our union suppliers and government partners, Canadian employees produced more than 10 million masks in less than a year. On April 8th, we fulfilled this commitment, and we couldn't be prouder of this achievement. That same speed and spirit of innovation I was just talking about, it's the same driver of our work to put everyone in an electric vehicle. That's because at GM, we recognize that climate change is real, and we want to preserve our planet for future generations so our children can breathe cleaner air. The future is electric. Our first EV designed for the masses was the Chevrolet Bolt EV, launched in 2018. It was the first affordable long-range electric vehicle on the market, offering a 383-kilometer range and starting just under 43,000 Canadian dollars. This combination of range and affordability made the Bolt the best-selling EV in Canada. But we didn't stop there. Today, we're dramatically expanding the number of EVs we offer, beginning with the larger Bolt EUV, and we have developed an entirely new global Ultium EV platform, which I'll talk about in a minute. That enables us to efficiently build a full range of EVs for every purpose. For people who want luxury, we introduced the new Lyriq, the Cadillac of EVs. This is the first fully electric vehicle from Cadillac, and it marks Cadillac's shift to an all-electric brand by the end of the decade. Every new Cadillac introduced after the Lyriq will be electric. Starting under $68,000 in Canada, the Lyriq offers more than 480 kilometers of range on a full charge. It also features high-speed direct current fast charging that gives customers an estimated 125 kilometer of range in just 10 minutes. The Lyriq has all the luxury and technology you expect from a Cadillac. Now, for others who want the ultimate in performance, we introduced the world's first EV supertruck, the GMC Hummer EV. It demonstrates the extreme performance capability of an EV. With 1,000 horsepower, 0 to 100 kilometers per hour in about 3 seconds, and for extreme road capability, it has a crab walk feature that allows the Hummer to drive diagonally. In addition, we have an extract mode for added ground clearance over obstacles. Performance like this usually is associated with internal combustion engines, not EVs. But this is exactly the point. Our EVs are designed to offer comparable, if not better performance across our vehicle portfolio, all with zero emissions and the help of artificial intelligence. By the end of 2025, just 4 years from now, GM will have launched 30 new EVs globally, 2/3 of which will be available in Canada. At the same time, we will have invested more than $27 billion in electric and autonomous vehicle products as part of our commitment to put everyone in an EV. Ultimately, our goal is to convert our entire vehicle portfolio to electric. Earlier this year, we announced GM's aspiration to eliminate tailpipe emissions from all new light-duty vehicles by 2035, and other OEMs are following suit. People are paying attention to our global commitments. Time magazine just named GM one of the 100 most influential companies in the world. In that story, Mary Barra put it best. Virtually all the assets necessary to achieve our vision, we have and have demonstrated. That includes the AI and engineering talent to support R&D and drive innovation right here in Canada. The heart of our EV strategy is a modular, flexible platform that we call Ultium. It has the power to make almost any vehicle an electric vehicle, and it will be the basis for all EVs in the future. This platform is made up of groundbreaking battery architecture, electric propulsion system, and high-energy battery cells. The beauty of the Ultium battery is that its common cells can be stacked vertically or horizontally inside the battery pack. This means engineers can tailor the battery energy storage and layout dependent on the vehicle design and capability. What's more, the Ultium system can be reprogrammed over time with new software, improving performance similar to how your smartphone is updated today. We are confident the Ultium platform will deliver industry-leading torque and power density across a wide variety of EV models. And it will be easier to scale because it consolidates many parts and features. This will play a huge role in making EVs cost competitive with the internal combustion competitors, while providing flexible vehicle options for a range of customers. Now I'd like to take a shift and focus from regular customers who buy our cars to talk about our commercial fleets. At GM, our vision for zero emission is not limited just to our own dealerships. We are also working to use our expertise and technology to electrify other industries too. As an example, we recently launched a new business called BrightDrop. This new business will help the commercial delivery business be greener and more efficient. To state the obvious, demand for e-commerce is soaring. Converting delivery vehicles to electric is a huge opportunity to reduce carbon emissions. The World Economic Forum expects e-commerce to grow by 78% by 2030, which could increase carbon emissions from delivery vehicles by more than 1/3 in the world's largest cities. Consumers are ordering more and more online, and the pandemic has only accelerated this trend. The first product BrightDrop is launching is the EV600, which we can see here in the picture. It's an all-electric commercial van made to deliver goods and services. It will be built on the Ultium platform with a targeted range of up to 400 kilometers on a full charge. And it will be built at our CAMI manufacturing plant in Ingersoll, Ontario. CAMI's assembly will be Canada's first large-scale auto plant converted to produce electric vehicles. BrightDrop not only eliminates tailpipe emissions from delivery vehicles, but it also makes delivery more efficient with the addition of the EP1, also known as the electric pallet. Engineers at GM's Canadian Technical Center Oshawa campus led the design, development of the prototype and the first batch produced of the EP1 with Canadian suppliers. Think of this as an electric-powered locker that the courier can use to deliver packages to multiple businesses on the same city block. As the visual shows, the EP1 travels besides the courier while he or she is walking to make package deliveries more efficient. So you can see we have a clear path to zero emission future. Now let's talk about autonomous technologies and how it will enable both zero crashes and zero congestions of our vision. This is where our AI technologies plays the biggest role. You may be asking yourself, why are we moving towards autonomous? We want to create a world where people we love more seamlessly and safely go through life. Unfortunately, that's not our current reality. According to the US National Highway Traffic Safety Administration, over 90% of crashes involve some form of human error. With human error still a leading cause of fatal crashes, self-driving cars could help save many of the 1.25 million people around the world who are unfortunately killed in traffic accidents every year. When you think of it that way, the question becomes, why wouldn't we want to embrace this technology? Accidents also steal our time, causing congestion and blockage of our highways and roads. You can think of this last time you had an idle traffic. You've been idle in traffic. What would you do if you could have that time back? How much more productive could we be? Just like we use one or more of our 5 senses to make decisions while driving, AI enables vehicles to make decisions by fusing not only parallel sensors like cameras, parallel to our eyes, but also other perceptors that humans don't have access to, like LiDAR, radar, and V2V communication. Because we have made strategic investment in the future, General Motors is a leader in the development of self-driving vehicles. With Cruise, our majority-owned subsidiary, we're determined to commercialize safe, autonomous, and electric vehicles on the way to driverless future, one with 0 crashes. We continue to make significant progress with our AVs, and we are convinced this technology will change the driving world and open up new opportunities for those who can't or choose not to drive. Cruise is deploying driverless vehicles in San Francisco area now that has received a permit from the Canadian DMV. This is huge, of course, because safely removing the driver in the true benchmark of the self-driving car. And it brings the future that is much, much closer than we think it is. In addition, GM, Cruise, and Microsoft will increasingly leverage Azure, Microsoft's cloud and edge computing platform, artificial intelligence to help commercialize self-driving vehicles at scale. If you drive a newer vehicle, it may already have the first stepping stones to a self-driving vehicle or future. In fact, our team of advanced driver assistance systems, otherwise known as ADAS, at the Canadian Technical Center Markham campus plays a big role in the development of these features. Technologies that rely on artificial intelligence, like forward automatic braking, lane keep assist, and blind spot detection, use sensors and cameras to help drivers avoid many of the most common crashes. And they're already available to customers today. General Motors and the University of Michigan Transportation Institute partnered to study the effectiveness of various GM safety-related features, and the results were dramatic. For example, GM's forward automatic braking with forward collision alert reduced rear-end striking crashes by nearly half, and rear park assist cut back-end crashes by 38%. These are just some examples of how AI can help keep our loved ones safer while out on the road. The next stepping stone to autonomous vehicles is Super Cruise, GM's driving assistance feature, and its successor, Ultra Cruise. Super Cruise enables hands-free driving on more than 320,000 kilometers on highways in the US and Canada. 2 years in a row, a leading consumer magazine has named it the top driver assistance system in the market. Super Cruise can now safely change lanes on demand under the right conditions. And we plan to keep expanding its capability and availability. So for the next 3 years, Super Cruise will be on 22 models across Chevrolet, Buick, GMC, and Cadillac brands. Our Canadian engineers were part of the global team who developed this game-changing technology and continue to do so. It uses 2 advanced systems: infrared facial recognition. This makes sure to keep drivers engaged, and a vehicle positioning system via a combination of precision radar, camera, and LiDAR-based mapping systems that help position the car very accurately relative to the planet. Driver assistance technologies like these would be the key to eliminating human error. Now you know our vision as a company, as General Motors. But let me tell you more about how GM Canada and its innovation ecosystem is playing a role in this future. The CTC has grown to become the largest software engineering and development center for GM outside the United States, and we're continuing to hire. We have 4 sites: engineering at our CTC Oshawa and Markham campuses, which I already mentioned. They are focused on developing software and hardware for advanced vehicle systems, including vehicle motion embedded controls, otherwise known as VMAC, ADAS systems, infotainment, and advanced technology work and AI innovation. We also have the Kapuskasing Proving Ground in Northern Ontario for our cold weather testing. And of course, the newly developed CTC McLaughlin Advanced Technology track right here in Oshawa. The Canadian Technical Center, Oshawa campus, is an integral part of GM's global engineering enterprise, using state-of-the-art technology to leverage engineering talent from all around the world. The Oshawa campus has full-scale vehicle design and development capabilities and focuses on chassis and body and connected vehicle subsystems. This 100,000 square foot facility has become a center of excellence for core innovation, alternative fuels, specialty vehicles, cold weather development, and complex project delivery. This is also the home base of our artificial intelligence innovation team. Our CTC Markham campus officially opened in January of 2018, situated in one of the largest information and communication technology clusters in North America. The Canadian Technical Center Markham campus is a 150,000 square foot facility featuring state-of-the-art test labs for software development. Here, our engineers are focused on supporting active safety systems, infotainment, and software for vehicles of the future. GM selected Canada as the base for these automotive engineering and innovation jobs because Ontario's innovation corridor is a talent-rich, pro-innovation incubator with an ecosystem of partners focused on transformational research and development. Our infotainment software group does a lot of work to enable drivers to be highly connected to their vehicles. This includes developing and integrating most of the applications found on the touchscreen, like wired and wireless phone projections, navigation, trailering, HVAC, and off-road capabilities. They also work on key components related to connectivity, like Bluetooth and Wi-Fi. Aside from driver assistance technologies, we also leverage artificial intelligence to enhance the customer experience through connectivity. Going back to our all-electric Cadillac Lyriq, one of the more dramatic details of this vehicle is the choreographed lightning that animates as you approach it. The Lyriq can recognize its driver and initiate a greeting with a choreographed lightning sequence, while also preparing the cabin for the journey, including seat settings, mirror, and climate system adjustments. This choreographed lightning relies on our KeyPass technologies, which was mostly developed by the connected vehicle team at the CTC Oshawa campus. Our KeyPass technology won the most prestigious internal GM engineering award in 2020, the Boss Kettering Award. To detect how far a person is from their vehicle, we rely on Bluetooth low energy signals between the phone and the vehicle Bluetooth beacon. The challenge is that Bluetooth is highly sensitive to water. And when our phones are either in our back pockets or backpacks, the signal is much weaker because of our bodies. And we need to select a different calibration table for this particular feature. All that's left now is to identify the placement of the phone when approaching the vehicle. So we started by doing some analysis, and this is where we take a deeper dive in AI technologies a little bit. By looking at the phone's gravitational acceleration data while walking, we notice a distinct pattern for each placement that's different from one person to another. But still, they're similar enough for a human eye to recognize, as we can see in the two graphs. However, finding the right mathematical model for this particular pattern was too complex or maybe even impossible, as it carries some level of uncertainty and needs to be generic enough to recognize anyone. We started then by collecting walking data from over a dozen people of varying characteristics, such as height and age. We then isolated the accelerometer axis that is most relevant to us, usually the one that has the most amplitude. We then segment the data into steps and encode it for the machine to train on. In this case, a simple feed-forward neural network was sufficient to achieve optimal performance that other traditional methods were not even able to get close to. Once we have trained a model, we group a few steps together to make an accurate prediction for the phone placement in real time. In this demo video, you can see how the classification of the phone placement would change in real time on the tablet facing the camera over there, as the phone changes placement on the person. This KeyPass technology does more than just choreograph the lightning for the Cadillac Lyric. It also allows customers to start their vehicle, lock or unlock doors without a connection to internet or using a traditional key fob. Looking at artificial intelligence across other industries, economic history has taught us that the impact of major innovations are often felt in the most unexpected places, by making critical tasks cheaper and more abundant. Similar to how Google made information search cheap and computers made arithmetic more abundant, AI makes prediction cheap, fast, and easily accessible to create competitive advantage. As we all know, prediction is a very versatile tool and can be applied to almost any activity of any industry, which changes the question from should we apply AI to where and when to apply AI. According to a study from McKinsey Center for Future Mobility, current AI applications are mostly focused on autonomous driving, justified by the historic existential race being a pioneer and first to market. However, we also notice that adjacent activities are also being explored and expanded, such as infrastructure inspection and quality assurance. This map can be seen as an arrow, where autonomous applications represent the tip of the arrow, as you can see here. For an effective arrow, having a sharp point is critical to hitting its goal. But to make the most impact, the arrow needs to also be wide, which is represented by the non-autonomous related applications of the automotive industry. A great example of product-related AI application is GM's partnership with Autodesk. GM took a big leap forward in automotive design to imagine a future of lighter, more efficient, and customizable cars. With the combination of generative design and additive manufacturing, our company can now explore new designs and efficiently make unique components to customize vehicles. Generative design is a way for us to explore different design solutions for parts and components for our vehicles by using cloud and artificial intelligence to combine the engineering and the computer. By getting them to work together, we can produce part design solutions that would be impossible to generate with either the computer or the engineer working separately. In an initial proof of concept, GM and Autodesk engineers applied generative design technology to reconceive a small but important vehicle component, the seat bracket where seat belts are fastened. The software produced more than 150 valid and safe design options based on parameters the engineer set, such as required connection points, strengths, and mass. The team zeroed in on one design, whose organic structure no human could have imagined. The new seat bracket is 40% lighter and 20% stronger than the original part, and it consolidates 8 different components into one 3D printed part, another major benefit to generative design. GM plans to utilize generative design on future product designs and as part of a multi-year alliance focused on innovation. GM and Autodesk will collaborate on projects involving generative design, additive manufacturing, and material science. I assume everyone here is either familiar or proficient in Excel, and how its automatic processing of numerical data has become an everyday commodity. Today, natural language processing is helping us process extremely large amounts of customer verbatim, be it online communication, call transcripts, or even customer feedback, while keeping the human in the loop for maximum performance. Natural language technologies are helping GM better listen to our customers so we can more reliably channel their feedback right into our products and services faster. This is something we focused on right here in Oshawa. By looking at the value chain of any company with similar structure to GM, we see ample opportunities for predictions applied to primary and support activities, driving for better products and profitability. Our Canadian AI ecosystem is a great representation of where AI is being leveraged. We see startups playing in AI contract negotiations to help us with procurement, anomaly detection for manufacturing, and route optimization for supply chain. As I mentioned in the start of the presentation, our growth in the AI space is continuing to accelerate. Our AI innovation journey at CTC started in 2017 with only one AI specialist. As we worked with leadership to prove the impact that AI can have on General Motors, our CTC AI team continues to grow faster than Moore's Law. The secret to this growth is to not focus on model complexity, but rather to translate AI enablement to actual business value that aligns with our company's objective and goals, and not focus on accuracies of models. All of this work will go even further now that we've opened the new CTC McLaughlin Advanced Technology track in Oshawa. The CTC MAT multi-million-dollar investment was announced in May 2019, at the time where GM invested $170 million in its Canadian operations. As of February 9, CTC engineers began putting their code to the road right here in Canada. This is a critical step in development, providing a safe area to test software we've developed often using AI before testing it in the real world. The CTC MAT was named after our founder and visionary, Colonel Sam McLaughlin. Colonel Sam was arguably one of the greatest Canadian inventors of his day. So it's entirely fitting that McLaughlin legacy and brand will now be part of GM Canada's ongoing transformation, and our next big step forward in advanced technology development and testing right here in Durham region. Finally, there's our Kapuskasing Proving Ground in Northern Ontario. This full-scale cold weather development facility officially opened in 1973. Around 95% of GM North America vehicles are tested in Kapuskasing. The rest of the tests of Automotive Center of Excellence Climatic Wind Tunnel at Ontario Tech University in Oshawa. All GM North America vehicle programs must complete cold weather exposure testing as part of their overall durability requirement, which is always managed by the Kapuskasing Proving Ground team. Our advanced driver assistance, vehicle motion embedded systems, and infotainment teams all leverage the test facilities in conjunction with artificial intelligence. To close out, I want to say that the future of AI at GM could not be brighter. As we continue to expand our in-house capabilities, as well as our partnerships and collaborations with ecosystem entities, both locally and globally, now we know that General Motors is doing to lead in a new world of AI and personal transformation that will be very different than it is today. We understand this moment in time is historic for our company and our industry, which have changed the world before and are about to do it again. What won't change is our focus on what customers in our communities and our promise to always see things not as they are, but as they could be. This is how we'll build a future that is safer, better, and more sustainable for all. Thank you for your kind attention. And now I'll open it up for questions. All right, I see that there already have two of them. Okay, so the first question, I'm going to read it out loud. How do you create test beds to measure the safety and effectiveness of some of your or our AI models? So testing AI models is one of the maybe greatest challenges of integrating AI, especially when it comes to safety features. And the reason for it is that AI is a data-driven modeling technique, meaning if the data is not rich enough that you trained on, you are at a risk of not being able to capture some edge cases. And for this particular reason, when we have an AI-based safety feature, our testing becomes the most important step. And we actually do iterative modeling to make sure that there are no particular scenarios that we are missing with our AI models. That being said, we almost never just put AI in a particular feature. What we usually do is we pair AI or data-driven models with physics-based models. So when the AI model is not able to take action or it didn't see that particular scenario before, we always have a fallback system for a physics-based model, which will never fail. The AI may have better performance, but just in case there are situations where it cannot operate, we always have another system to take over. All right, let's see a second question. Does GM also offer AI training and upskilling to their development staff? Absolutely. Actually, I want to say a little bit more on this particular topic. General Motors is a legacy company, and we hire talent all the time. When AI came to light at General Motors, one of the things we decided that was important, sometimes even more important than the talent itself, is what we call AI culture within the company. Being able to explain to engineers how AI works, and the fact that it is a black box, it doesn't mean that we do not really know what's happening in there or we cannot control it, and showing them how it can work hand in hand with our other algorithms or with a human in the loop has created a lot of acceptance for the AI technologies internally. And as part of our AI culture within General Motors, both here in Canada and in the US by Canadian talent, we have focused a lot of our energy into providing training and upskilling of our employees in the AI technologies. In our AI innovation team in the Oshawa campus, we hold brainstorming sessions, we hold seminars and courses, sometimes also in universities, to make sure that the talent is always developing. Okay, I see another question. Where are some of the skill sets you look for in a new hire for AI projects? Well, this is a great question because I'm currently in the process of hiring 8 new AI specialists to the team. And really what I look for are 2 things. One is, actually maybe I'll rephrase, it's 3. The first thing is a fundamental understanding of the theories behind AI. And it really depends on the team that you're joining. If you're joining a team that is focused on just applying AI, then the fundamental understanding may be less relevant. But in our case, we do some research before we start innovating in our products with artificial intelligence. So we look for that fundamental understanding of theoretical background behind AI. Because in a lot of cases, the off-the-shelf AI libraries and products are not really sufficient. They don't really meet the need that we have. So we have to create our own libraries and our own algorithms. And to do that, we need that fundamental understanding. The second thing are coding skills. So we usually mostly use Python, but we have come across some people who are really strongly committed to the theoretical background, but when it comes to applying that theoretical knowledge into the code, there's a bit of a mismatch. So you either have 2 teams, one that is focused on transforming the knowledge into code, or the other approach which we're taking today at the AI innovation team is to have both skills in the same person, because there's no better person to transform the idea into code than the researcher themselves or the data scientists themselves. And then the third point I look for is more behavioral. AI is still an innovation technology. And what we need people who can be proactive, who can come up with ideas, who can come up with new perspectives of looking at particular problem and not be limited to what's in the research area or papers or publications that are coming up recently. So that's really what I look for personally in new AI talent that we hire. So next question is, not all data sets are clean to work with. We are working with models that utilize more fuzzy logic. How do you factor this into your work? This is absolutely the single most important thing we try to work on the onboarding process of a new hire. Because usually, if we're looking for someone who's fundamentally strong, they probably have some graduate studies or degree that really, when they got it, they really only worked with clean data sets. Because in the academia, most of the data sets are clean, they're properly labeled, and the data source is really straightforward. When it comes to the industry of real world data, it is almost never the case. And pre-processing takes 70 to 80% of our time to work with data sets that we have today. We also have to take into account that for a company like General Motors, we started collecting data decades before we even realized that there isn't technology such as artificial intelligence to apply that data to AI. So it is really a colossal effort by our IT department to make the data available to us, but also it puts a lot of layers of complexity for the AI team on how to handle this data that may be unbalanced, may be noisy, and in a lot of cases, we actually say that the data is not good enough. To do that, at the AI innovation team, we start every project by what we call a technical feasibility assessment. And by what we mean by that is knowing that you have data and we have a method in AI and the AI toolbox that can solve it, doesn't mean that we can guarantee results. So we definitely always spend some time to make sure that the data is rich enough to get the insights the customers are looking for. Okay, last question here. Can we know about the current obstacles which you face in the industry with regards to applying AI? One of the biggest challenges that we just discussed, which is the availability of clean data. That is never the case, and it really translates. This really translates to more of a business problem, because people who come from the business world, they're really used to a more sequential, more certain, more straightforward way of thinking in terms of like, tell me how much you need to get this done, and it will be done. And they will give you the resources. However, in machine learning and AI, it is almost never the case that you can predict how long it's going to take you or the performance of your models. So one of the biggest challenges we face is how to communicate to our leadership that this process, even though we see, let's say, good accuracies in these scenarios, doesn't mean it's ready for production. We need to do a lot more testing, or we cannot perform this particular task with the data we have today. We have to change the way we collect data so we can get better quality data to get the model trained properly. So that is, I would say, one of the biggest challenges we face. The second one would be access to good talent. Right now, especially after the pandemic or towards the end of the pandemic, we're seeing a lot of more demand from companies in the US and globally, because now they're offering fully remote positions. So competition for talent, especially in the AI space, it's never been easy before, but now especially, it's more difficult than ever before. That's why we look forward to the AI talent that is developed here locally in Durham region and the Canadian ecosystem. And with that, I thank you for your attention.